Yeah, I believe that's all the time we have right now. Maybe Sanil, we can check out the demos then.
Yes, yes, yes. Shulin and Himanshu will showcase the CSI plug and play, and Shulin will take the anomaly part of it.
Right. So just to give you a heads up, SODA releases are named alphabetically and after the names of islands. So if you want to check out the names of previous SODA releases, head on over to docs.sodafoundation.io and you should be able to check out all the names of our previous releases. This is very important, so please do your homework right away. But today we bring you a preview of our next release, which is the H release or the Hawaii release, which is going to happen in a couple of weeks' time. So just to give you a quick preview and sneak peek into what you can expect in the next release are SODA maintainers Shulin and Himanshu Vashne. Over to you, Shulin.
Oh, okay, thank you. So Amit, can you open my video? So I don't have the permission.
Ashit?
Shulin, you can see this slide?
Yes. Thank you. So hello everyone. I'm the maintainer of SODA Foundation. So I was working on the different projects in the last few months. So, okay, wait a moment. So definitely the name is very interesting, and it comes from the Spanish and dolphin. So and before we go into the demo, I will introduce the SODA architecture and some key flow. So here, so what is different? So different can be regarded as an infrastructure, data, O and M and framework. Currently, it has three main features. So collect data, watch data, and push data. It provides the RESTful APIs for discovering and configuring remote devices for data connection. It also supports different connecting tasks, such as the configuration data and the align data or performance data. To simplify the data collection, so we define some unified model. Like Sanil said, it's very difficult for us, but it will simplify our data washing and data pushing, such as the performance matrix, IOPS latency, or bandwidth. Considering the diversity of devices, we also define the driver interface to help developers to write the adapter for different devices. The last step of data collection is to push the data to the third-party platform, such as promisers. The data exporter mechanism also allows developers to write the data exporter to their platforms. Okay, next slide, please. This is about the performance monitoring key flow. So firstly, we can say, and we use the Quant service to trigger Delphin to start the data collection. When the Delphin API receives the request, it will get the basic device information from the local database and get a knock from the Redis or the keeper to prevent the repeated task during task execution. Then the Delphin API will use the message bus to distribute the task message. The task manager here will receive the task information to generate the task execution threads. Each task thread will collect data from the related storage device based on the task type or the device information. After the data collection is completed, the data execution thread will invoke the exporter to push the data to the promisers here. Except the performance collection, it also supports the configuration and the align data collection. Okay, the next slide. In terms of alerts, so we also support the SMP traffic receiver to get aligned in real time. So the first 4 steps show the how user to configure the SMB trap information, such as the alarm source IP, SMP v2 or v3 information. If the user doesn't configure it, the trap receiver will drop the alarm UDP package. So when the store device become an abnormal, an alarm will be generated and reported to the alarm trap receiver. The alarm trap receiver will pass the alarm UDP package and send it to the driver to pass the OID data to the unified alarm module. Then push the alarm to the alert module here. So this is some key flow of different. So let's go to the demo part. Hello? Oh.
I think he's sharing the demo right now, yeah.
Yeah, you can use full screen. Oh, yes. Here, we can show the storage summary, and so go to the a specific storage device. So at first, there's no data for performance metrics.
Can you make it full screen, please?
The user can configure and the performance, enable the performance condition and disable it. So the user can configure it here. After the user config enable the performance condition, then the data will collect over time. So such as here, the data is collected here. This is response time by different divisions. And we also can the whole, this is the whole data. We support the bandwidth throughput and IOPS. So here, this is storage monitor page, and the user can collect the different storage to filter the matrix picture here. So it's grouped by the matrix. So currently we just support the I think 4 matrices: the response time, bandwidth, and the latency. Throughput, sorry. And the list is this is the alert manager. This is from the permit alert manager. The user can see the different different services alert information here. So they can see they can collect relate the alert to the matrix information here. And they can open the information to show the detail alert information here. Okay, thank you. That's the dev workers current. So I think the Himanshu will take over the next, the CSI plug-in play.
Himanshu, whenever you're ready.
Himanshu, you can start.
Yeah. Can you share the demo?
Is the demo visible? Or
No, we're still seeing the Delphin demo.
oh, just a minute. Can you see it now?
It's still a Delphin demo, Ashit.
Is there any network lag because I'm sharing? Just a minute. Just a minute. You can see the screen now, right?
Yes, please. Can you just make it high definition? Okay, all right. Thank you.
Ashit, can you pause? Start from. I have the control, right?
You want to control, Manshu?
Yes, yes, yes.
Yeah, you can take the control.
Okay. So hi everyone. This is Himanshu. I'm currently contributing to Soda. So this demo is to give you an idea about how third-party CSI drivers from different vendors can be directly used seamlessly, and how the Soda profile management can be useful to manage and provision storages from different heterogeneous storage drivers. So yeah, so let's go to the demo part of it. Yeah, cannot play. Ashit, can you start play? Okay, so this is the deployment. So there we deploy the sidecar containers for these to support like for node as well as the control part of our operators. So this is a high level call flow from how the user can use this CSI plug and play from different storage vendors. For this POC, for this demo purpose, we have used two CSI drivers, one for IBM and one for like LVM native LVM driver. And what it does, like the user sends the storage provisioning request to the API server. Basically, it is the server provided by the Soda. We have different components for Soda, like API server, dock controller, and once the request arrives to the API server, then we have these plugins like Soda CSI Provisioner, which watches on the drivers for any updates for the request. So any request comes directly that can be managed using the Soda profile management for which driver the call has come to, like to provision the kind of volume. I mean, to provision a volume from the individual drivers. So the profile management comes in picture to take the call to the respective driver to make the calls to create a volume. So these are like we for this demo purpose we use this LVM driver as well as the CSI driver. So the first step is to create operators for these respective CSI drivers. So for this, like we will create operators for IBM. You can see the pods. We can list the pods. So these pods are in the running state. So now, yeah. So we can list the respective LVM driver as well. And now to list down like how the provision takes place with respect to SODA. So SODA has profile management. So we need to supply the profile ID, respective profile ID for each driver. So the customized profile mapping has been done for each individual CSI driver. So we provide this profile ID to the storage class pod and the configuration file. And based on this profile ID, the pod basically identifies the call has made to this particular CSI driver. And we can deploy this pod. And now we can verify using the logs that the correct volume creation request has been passed to the pod. Yeah. So we can verify from here that the IBM respective driver volume creation has been passed to the. Now similarly for LVM can be done. So we have these two profiles created individually for IBM, one for IBM, one for LVM. So now we need to provide the LVM storage uh, driver profile ID to the storage class configuration. And then we can deploy this. Yes, and thus logs can be seen to identify that the correct call has been passed to the respective CSI driver to make the provisioning happen at the backend. That's it. And this is all about CSI plug and play demo. Thank you. Anvit, over to you. Hello.
With
Hey, hello everyone.
Anvit
Thanks,
got
Sanil.
disconnected.
Thanks, Kiran.
Yeah, go ahead. Ashit, go ahead.
Yeah. Thanks, Himanshu, Shulin, and unfortunately, Praveen was busy, so we could not. He has some personal emergency. Yeah. So thanks a lot. That was a very good. Like we now know that what all are the upcoming things, upcoming technologies, that cutting edge technologies that we are going to work on. And yeah, definitely there are lots of things to do and lots of interesting things coming in our upcoming releases.